In this video, we're talking about place value and fractions to decimals. So right here, I have our place values written out, and I just wanted to draw attention to one thing. It really is a mirror image of our ones place. So we only have one ones, and then everything on this side will actually repeat and be everything on this side. So you'll notice on this side we have tens, and on this side we have tenths. So that THS is telling us that we actually have a part of a one instead of having multiple ones. So this would be like having $10, and this would be like having a tenth of a dollar, right? So then if we keep going, this is having $100, and this would be like having hundredths of a dollar, which would be like your pennies. And then it goes on and so forth down as it mirrors going up, okay? So now, when we read a number, we want to read the comma with it. So if I have a number like 4,375,216, if I have this number, then I say 4 million. So like this comma is the million, 4 million. And then I read it in groups of three, 375,216, and that is my number. That is how I read it. Now, on the opposite side, we actually read it exactly like we would on this side, but then we name the place that it ends in. So, for example, if I have 0.5, it actually is, if it was just that, we would say 5. In this case, it's 5 tenths because it ends in the tenths place. And as a fraction, you can see 5 tenths when you write it. 5 tenths, that's how you would say that. So if we have another 0.12, this one is 12, so just like this, 12, and then it ends in the hundredths, so it's 12 hundredths. 12 hundredths. And we can do it again. So if I have 0.345, you'll notice that that one ends in the thousandths place, so we'll say 345 thousandths. 345 thousandths. So as a fraction, you can hear what it should look like when you read it. Even if it gets further than that, which a lot of times you won't see it get further than that, but I'll show you what 10 thousandths looks like. We read it without a comma, but please know that if it was on this side, there would be a comma, right? So we read it like 1,506 10 thousandths. So 1,506 10 thousandths. And that would be our fraction form of it. What you should notice is the number of digits behind the decimal. So in this case, there was 1 digit. There was also 1 zero. In this case, there were 2 digits. There were also 2 zeros. 3 digits, 3 zeros, 4 digits, 4 zeros. So that's another little trick that you can use, turning a decimal into a fraction. I want to draw attention to if it has a 0 on it, that 0 is still pushing the place value. So this would be different than this one. This is 5 tenths. This one would be 5 hundredths. So you have to count the zeros that are pushing our numbers away from that. So this would be 5 hundredths because you have 2 digits behind your decimal. So you would have to have 2 zeros in that denominator. So that's kind of how we read the numbers. Now, let's talk about working with fractions and getting them to decimals and mixed numbers. So we know, and I've been having you guys do this, we know that we can take 3 1/2 and get it into a mixed number. But I really want to show you what it's doing. 3 means we have 3 whole of something. I don't care if it's candy bars or pizzas or whatever you like, all right? And then we have half of one. So we only have this. So I am going to shade all of these in. What we want to do is we see that we have 3 1/2. That's what it looks like as a mixed number. To get it into an improper fraction, what we need to do is we need to take these 3 wholes and cut them up into two slices each. So we would cut there, we would cut there, and we would cut there. So that is why you take the denominator and you times it by the whole number. You're actually cutting up into that many slices. So now we have 1, 2, 3, 4, 5, 6, 7 halves. Do you see that? So if I say 2 times 3, it's these 6 halves, 1, 2, 3, 4, 5, 6, and then you need to add the top number for this partial. So 2 times 3 is 6 plus 1 is 7, and we can't just say it's 7 because really it's not 7 wholes, it's 7 halves. You can say the same thing if it's like 1 and 3/5. Well, I have one thing cut up into 5 slices, and I have all of those slices, and then I have another thing cut up into 5 slices, and I have 3 of those slices. This is my whole, and this is my partial. So to get it into an improper fraction, we would just say 5 times 1, because we cut this one up into 5, plus 3 is 8/5. So that's really what it's doing when you're taking that mixed number and turning it into an improper fraction. You're really just cutting up your whole numbers into whatever you need it to, and that denominator tells you. But you need to keep that denominator the same because you haven't changed the size of piece. The next part that I want to go over with is whenever you guys are taking it from a fraction into a decimal, it's always just top divided by bottom. So in this case, we would go 7 divided by 2, and we would get 3.5, all right? In this case, we would go 8, because it's our top, divided by 5, and we would get 1.6. All right? Now, for whatever reason this is difficult for you guys and you guys forget if it's top divided by bottom or bottom divided by top, if ever you forget, test one that you know. So what's really easy is a quarter. We know that 1/4 is equal to 0.25. If you forget whether it's top divided by bottom or bottom divided by top, just throw in something that you know, and if you get 0.25, then you know it's top divided by bottom because it's 1 divided by 4. If you get 4 divided by 1 is equal to 4, well, a quarter isn't 4, so you know it has to be the top divided by bottom. So sometimes checking things that you know for sure will help you with things that you're unsure about. I think you guys will do great.